In today's field of AI, questioning large language models or LLMs has become a common practice. However, have you ever wondered what the best way to interact with large language models? How can you craft prompts that generate accurate and insightful responses? Or how about creating a game prototype directly using natural language prompts? Hello everyone, I'm Haowen Huang, a senior developer advocate at AWS. And today, I will be sharing best practices for prompt engineering with demos to create a game prototype purely through natural language interactions on Amazon Q and Amazon Bedrock. Get ready to gain practical knowledge and see real examples that will enhance your understanding of this crucial aspect of working with large language models. Let's dive in. And here is the agenda for today. First, I will provide a straightforward and engaging example to help you understand the mysterious concept of prompt engineering. Next, I will present 2 demos to create a game prototype entirely using natural language prompts. I will not modify any code generated by the large language models. The first demo will be conducted on Amazon Bedrock, and the second one will be conducted on Amazon Q. After these 2 demos, I will discuss best practices to follow when performing prompt engineering tasks. These tips will help ensure you maximize the potential of this powerful technique. What is prompt engineering? Imagine ask a large language model what is 10 plus 10. The likely response would be 10 plus 10 equals 20. However, consider if you wanted a different correct answer. The question is ambiguous. It doesn't directly ask to solve the math problem. For example, if teaching order of operations, you may want the large language model to identify the operations type instead of solving the problem. 1 plus 1 is an addition problem, and 1 minus 1 is a subtraction problem. 1 times 1 is a multiplication problem, and 1 divided by 1 is a division problem. With this context, asking what is 10 plus 10 would prompt the large language model to respond 10 plus 10 is an addition problem rather than solving it. The large language model generates responses based on the provided context. The same question prompts different responses when given different contextual information through prompt engineering. So in demo number 1, we will explore creating the classical greedy snake game using Python and the Llama 3.1 70B model on Amazon Bedrock. This project showcases the model's capability to handle complex logic programming and develop a graphical user interface. While the game's rules seem straightforward, implementing all its features perfectly is still a challenge. The code will require mastering the snake's movement, random food generation, scoring systems, and game over conditions and other aspects. Firstly, let's go through the prompt we intended to submit to the large language model. This is a prompt script for demo number 1. The prompt provides specific instructions for the model to follow when writing the code. For example, the code should be written with assumptions that the intended reader is an experienced developer, so only ambiguous portions should have commas included. Importantly, the prompt directly states that no code should be generated before the triple-quoted Python block. After generating the code within that block, the model must carefully review its work to ensure there is no mistakes, errors, or inconsistencies. If errors are found, they should be listed in text, and the new version of those errors fixed should be generated. If no errors are present, the text should indicate checked, no errors. The task is clearly defined. Write a greedy snake game. What you see now is a chat playground of Emerald Bedrock. And I have selected the Llama 3.1 70B Instruct model to perform this task. First, let's copy the prompt we introduced in the previous slide into the dialog box and review its content again. So we review the content to define our how the large language model should do with the task. And we also definitely define the task write a graded snake game. After confirming the context, click Run to submit the prompt to the model. Within seconds, the model will begin generating and outputting the code. You may be curious whether the code generated by the large language model actually works or not. Therefore, after all the code is generated, I will copy it to VS Code on my laptop to test and demonstrate how it can work or not. You may be curious why I have 4 Python files here. The reason is that I tried 4 times to copy all the code generated by large language model without modifying a single line to evaluate if it was runnable or not. I was unsuccessful in the first 3 attempts, but on the 4th try, I finally succeeded in getting the code to run correctly. And here is the code. You will notice that the code generated by the large language model have a professional style and provided a concise yet clear comments for each implemented features. For example, it included code and comments for initialize the games, setting up the snake, generate a random food, establish the scoring systems. Click on the triangle icon in VS Code to run this code. Yes, this is the greatest snake game we played in our childhood. Although the visual effects in this game are still not perfect, the basic functionalities are clearly presented to you. For instance, the small red square represented the food, and the green rectangles represent the snake's body. So after the snake eats the food, the score increased by 1 point. If the snake collides with any of the 4 walls, the game is over. So this is the snake game that I directly generated based entirely on natural language prompts without writing any line myself. Even a person who doesn't understand programming at all can generate such a game prototype through natural language alone. This demonstrates how our world has changed, enabling everyone, whether a program or not, to create their own cool applications using large language models. If you are interested in the details of the entire processing of creating the greatest game, you can refer to my blog post. You can scan the QR code displayed or check out the blog post link provided in the descriptions to access the full details. In the first demo, we utilized Emerald Bedrock to generate a prototype of the greatest game, which requires having an AWS account. If you do not currently have an AWS account, you need not worry. You can use Emerald Q to generate the greatest snake game and still experience the power of generative AI. And this is what we will showcase in demo number 2. In demo number 2, we will use the same prompt that we used in demo number 1 and submit it to Emerald Q. The only difference is that we will prefix the prompt with /dev, which indicates that we will be utilizing the capabilities of the Emerald Q developer. First, we navigate to the VS Code interface, where we will submit these prompts to the Emerald Q. You can enter / in the dialog box to see a list of quick actions. And here we selected /dev to utilize the MLQ developer features. Next, we input these prepped prompts after /dev. Finally, we double-check these prompts, especially confirming that the task we are giving MLQ is write a greedy snake game. Then we can submit it. After submitting, we will see MLQ responding, generating the code. Yeah, submitting. And MLQ responding, generating the code, which indicates that the MLQ is in the syncing phasing. Let's quickly review the output from the MLQ developer. First, let's examine the summary of changes section, which summarizes the thought processing of MLQ in 4 points. It initially checked if there are any existing local code files that could be reused, but finding none, it politely apologized. And then it states that it had completed the task and generated a Python code file named snake_game.py that can fulfill all the required functionalities. It mentioned that it had carefully reviewed the code, including game initialization, the main game loop, and other key game functions. Finally, it asked, would you like me to add this code to your project? After confirming and clicking the green Insert Code button, I can find the snake_game.py Python code file in my local directory. If you review the full code, you will find that the generated Python code has concise and complete comments based on the prompts we provided to the MLQ. So in VS Code, after reviewing all the code generated by the large language models, the only thing we need to adjust to click the trigon icons to execute this code. And the code generated by the MLQ causes the snake's body to move at a relatively fast pace. If you, like me, are not an experienced game player, you can continue to request assistance to the MLQ to modify the code and adjust the movement speed of the snake's body to a suitable level. Similar to the previous blog post where I demonstrated generating the greedy snake game using Bedrock, I have also written a blog post to help developers learn and refer to the process of creating a greedy snake game prototype using MLQ. In this blog post, I have additionally requested assistance from MLQ in modifying the code to adjust the snake's movement speed. You can scan the displayed QR code or check the blog post link provided in the description. We have witnessed 2 demos of generating a greedy snake game prototype through natural language prompts. It is now time to evaluate the insights gained from these 2 demos and, more importantly, attempt to summarize the best practice of prompt engineering. To design effective prompts for large language models, following best practice is essential for achieving the desired results. Let me explain some key considerations. Firstly, clarity and conciseness are crucial. Prompts should be clear and concise. Avoid unnecessary details that could confuse the model. State your task precisely. Secondly, provide relevant context and background information to help the model better understand the task. This could include details about the subject matter, the intended audience, or any specific requirements. Thirdly, use clear directives or actions words like explain, summarize, or generate to guide the model on the type of response you expect. Furthermore, Starting your prompt with a question can be an effective way to frame the task. Providing one or more example responses can also be helpful, as it allows the model to better understand the type of output you are looking for and adjust its responses accordingly. For more complex tasks, consider breaking them down into smaller, manageable steps. This can help the model tackle each aspect more effectively. Finally, don't be afraid to experiment and be creative with your prompting approaches. This slide presents the primary resources I consulted in preparing this session. If you found today's discussion on prompt engineering or developing generative AI or large language model-based application engaging, I encourage you to explore these valuable resources and gain practical experience from them. That covers everything for today. The field of large language models is still rapidly evolving, and I will keep you updated on the latest breakthroughs over my LinkedIn page. You can find the link in the description. Thanks so much for watching. If you enjoy this video, be sure to like it and subscribe to the AWS Developers YouTube channel. I look forward to connecting with you again next time.